Hi everybody and welcome to a new video in the melody generation with long, short and memory networks series. This time we're going to delve into some basic music theory concepts. Now you may be wondering, but why do I need to know about key? Why do I need to know about time signatures? This kind of like weird musical stuff. Well, it turns out that if you want to create models that generate music efficiently or effectively, so you should definitely know a little bit about the musical domain. And that's because music is a highly complex process, and in order to understand how your models are doing, you want to learn one thing or two about music theory. Okay, so today we're going to talk about a bunch of different topics, like for example time signatures, notes, pitch, MIDI notes, transposition, keys, all of these kind of things really. And then on top of that, we're going to look into how we can use this information for building a music representation that works well and that can be directly fed into a neural network for training purposes. That's good. Okay, so let's get started. So last time I mentioned that a melody at its core is just like a sequence of notes and rests. And here we have the Western traditional notation, as you can see it here, right? And so you have all of these different musical events or notes, and time is kind of flowing from left towards the right. So each of these symbols is a musical note. I'm sure that every one of you will be aware about what a note is, but let's try to define it in a way that's unambiguous. So a note will give you information about pitch and duration. Okay, so we'll take a look at these two components one by one. So we'll start with pitch. So pitch obviously indicates how high or low a note is, and it's strictly connected to the concept of frequency. The higher the frequency, the higher the pitch of a note. Good. Okay, so here we have basically all the 12 notes that we have in our Western musical system. And as you can see it here, we have the note names. So we start from this C, and we go up to C sharp, D sharp, all the way until this other C over here, right? And so one thing that I want you to understand about this notation is that the higher we go in this musical stuff, the higher the pitch of the note. So let's listen to this scale, which by the way is called the chromatic scale, and that divides the octave into 12 equal parts. Here we go. Good. Okay, so as you can see here, while I move up on the staff, the notated stuff, the pitches go up as well. Now, you might notice, as I mentioned, that we have two C notes here. So one is notated down here and the other one here at the end. Well, but what's the relationship between these two notes? They're definitely not the same, but they somehow like resemble like one another. It turns out that the second note, this second C, has twice the frequency of like the first C down here, and this is called an octave. Good. Okay, so we'll take a look at this like in a second with an example, but before that, where I want to draw your attention on is that, okay, so here we have two different C notes, but still we notate them with the same name, so C. So just the note name is not enough for identifying a note unambiguously. We need also information about the octave. And so this is where the scientific pitch notation comes in. So in the scientific pitch notation, we have two elements to identify a note. So one is just the note name, so C, D sharp, F sharp, G, for example, and then we add a number which indicates the octave we are currently in. So for example, here we could say that this note here is C3, right? So it's C in the third octave, then we have D4, A1. Right, but now you may be wondering, but what are like these octaves and how do we recognize them? Well, it's quite straightforward. So here you can see a keyboard, piano keyboard, and it's mapped onto like all these different notes. So here we have like the C1 notes, which is all the way down here. Then we go up an octave and we have the C2 note, C3 note, C4, all the way to C8. Now, all of these notes can be mapped down here in the Western musical notation. And as you see, the higher we go, and in terms of pitch, of octaves, and the higher we go here, like on the staff. But you may be seeing like this point, which is kind of like discontinuity, because when we pass from C4 and then we go down here like to C4 or like even C5, it seems like that we're going down, but that's just because we're moving from this bass clef that's used for notating music for low frequency instruments like the double bass to the treble clef, which is used for other instruments that are higher pitched, like the flute or the violin. Now, so let me show you what I mean when I say that all of these C notes will more or less like sound the same, even though like they are clearly different in terms of like their height. So so here you see that we start from C4, we go down to C5, C6, 7, and then we go all the way back to C3. Let's listen to this. Right, so as you can hear, the quality of these pitches, of these notes, is the same. And in music information retrieval, we call this quality chroma. So the chroma of all of these C notes is the same. What changes is the octave. Now, again, I want to stress here that in an octave, we have 12 different pitches. And these are like the fundamental pitches that we use in the Western musical system. Obviously, if you were to analyze other types of music like Indian ragas or like African music or Arabic music, they would use completely different scale system or pitch system. But for now, we are just focusing on the Western musical tradition here. Okay. So now let's go back to like our melody that we've learned to recognize like over the couple of this video and the last, right? And so we can map all of these notes to their note names. And so here we go. So we have C4, then we go to D4, E4, E4, F4, D4, right? It's just like a one-to-one mapping between the notes and the actual symbols on paper. Or it's not paper, this one, but the digital symbols here and the respective like notes and note names. Cool. Now, this is a great system like for representing music, but in our series, we're going to be using another way of notating pitches. That's called the MIDI note notation. Now, MIDI is a very big topic in itself, and I'm not going to cover that in this series. But all you need to know for now is that MIDI is kind of like a protocol that you can use like to play, to edit and record music. The whole point of MIDI, which came out, I believe, like in the 80s, is that with this protocol, you have different digital instruments that can interface with each other, and these instruments can be also interfaced to a digital audio workstation. So basically like some music software where you can just manipulate like these symbols, right? So the point is that in MIDI, we have a bunch of different MIDI messages. Like for example, when we play a note, so we have like, for example, a MIDI note on message, and with that we should provide information about the note, the pitch of the note itself. And so the way MIDI handles that is by using some integer mappings. So basically all the note names are mapped to certain numbers, integers to be specific. And if we take the middle C, which is the C at the center of the piano keyboard, that's mapped onto the integer 60. Good. So here we have like all the mapping between note names and MIDI note numbers. And as you can see here, we can start here, like so C4, middle C is 60, then when we move like a step up, we have to add 1. So C4 sharp is 61, D4 is 62. If we go down by a step, we have to subtract 1. So for example, B3 is going to be 59. So it's quite straightforward. It's a way of encoding note names using integers. Good. So we're going to use this in our music representation. Okay, so now if we go back to our sample melody, you see that we can map the notes here onto their respective MIDI note numbers. So this note is 60, then we have 62, 64, 64, that is this E4 note, and so on and so forth. That's all good and well, but we know that a note is not just information about pitch. It also has information about the duration, so how long I have to hold a note in a performance, right? Okay, so with that idea comes like this thing called like note values. So these are all symbols that express information about the duration of a note. Okay, so we start from like this initial symbol over here that's called a whole note. And as you can see here, we have a hierarchical tree that's basically like a binary tree. And at each level, we can go a level down, which divides the duration of a note by 2. Okay, so as I said, we start here with the whole note, which is equal to 4 beats. Now, I'm sure many of you know what a beat is, but I'm going to explain this a little bit more in detail in a couple of minutes. But for now, think of the beat just as a unit of measurement for duration, really. Okay, so here we have like 4 bits for the whole note. If we go one level down in this tree, we have a half note that which duration is 2 bits. If we go yet another level down, we arrive at the quarter note. And as you can see here, this is a quite important level because a quarter note usually equals to 1 beat. So a quarter note, in a sense, is the kind of like a point of reference for note durations. Then if we go down, we have eighth notes, which are worth like half a beat. And if we go down to the bottom level, we have 16th notes. And each of these notes is worth 1/4 of a bit. Now, if we want to equate the duration of a whole note in 16 notes, obviously we're going to need to have 16 notes, right? So these names, these terms, right, for like these musical objects are not surprising at all, right? Okay, so now let's try to map these like our melody onto like its relative correspondent durations here. Okay, so here we have like these 2 initial notes are quarter notes, and so they're worth like 1 bit each. Then we have 4 half notes, and these are basically worth 0.5 bits each. Okay, so an interesting like thing that you should learn about melodies is that, or music in general, is that they are divided into bars. So bars is a kind of like self-contained amount of like durations that has its own like metrical structure and accent structure like in the music itself. And to identify the end of a bar, not surprisingly, we use a vertical line or a vertical bar, right? So this is bar number 1 and this is bar number 2. Now I want you to add up the duration for the 2 separate bars. Okay, so if we do that, we find that the duration in number of bits is equal to 4 in the first bar and 4 again in the second bar. So you might have noticed that here we have this weird like sign. So 4, 4, it's like a fraction sign over there. So probably it has to do with like this duration in number of bits, right? And indeed, that's called a time signature. And the numerator tells us the number of beats we have in a bar, whereas the denominator tells us the type of note which equals to 1 bit. And if we have 4 here, it means that the quarter note is equal to 1 bit. So here basically we have 4 quarter notes, so 4 bits in a bar, where each bit is a quarter note. So we've been talking about bits like for quite a while. So what is the musical beat, right? So it's kind of like an ambiguous term, but basically you can think of it as the unit of duration, the unit of time in music, and it corresponds to the pulse of the music. Another way of defining it is that metrical level, that duration level you tap your foot like onto when you're listening to some music and you're following it actively, right? Okay, so that's the beat. Now, let me show you a few different examples of time signatures here. So here we have, for example, 3-2, quite uncommon time signature. And this means that we have 3 beats and the duration for each bit is a half note. So in 3-4, we have 3 bits once again, but the bit is identified with a quarter note. And then we can move on to 3-8 and 3-16. It's the same thing. So we have 3 bits once again, but the bit duration, for example, in 3-16 is a 16th note. So here I want to show you like an example of music of a very, very simple melody in 4-4 and 3-4. So to let you like understand like the difference here. So this is like super dull, but it gives you an idea of like how this music is structured. 4, 1, 2, 3, 4, 1, 2, 3, 4, right? So this is like a typical 4-4, and I should say that probably 90-95% of all like popular music like is in a 4-4. That's like a very, very common time signature. Here we have another quite common time signature that's 3-4. Let's listen to this. 1, 2, 3, 1, 2, 3, right? So this is basically like the difference between the two. Now, you may be wondering, but why should we care about time signatures? Well, it's important that you learn like what these time signatures are, because the melodies are going to be shaped differently depending like on their time signatures, because like the time signature brings in itself like the shape of the melody, the accents like of the melody. And so we want to know, we need to know about time signatures, because we want to understand whether or not our neural network that's generating melodies has learned time signatures, and most importantly, if it has learned how to create music in 4-4 or in 3-4, and because like that music is going to sound and is going to be like very different. Okay, so one last piece of music theory that I want to teach you today is the concept of key. Okay, so the key is quite abstract concept, but is so fundamental to Western music that's based on harmony, right? Okay, so key, like at its core, is just a group of pitches, or if you will, scale, that forms the core elements of a piece. So we use all of this pitch content as the main content for a piece of music. And that's more or less the idea of a key. And a key is formed by two elements. So one is the tonic and the other one is the mode. So, and when we indicate a key, we usually use both the tonic and the mode. In this case, we could say, like, here we have a couple of examples here. So this first key is C major, C being the tonic and major being the mode. And here we have D minor. Okay, so let's take a look at tonic and modes, like more into detail. So what's the tonic? So we can call it tonic or tonic note, and that is basically the pitch that provides a certain sense of arrival, right? It provides you like with a sense of rest. It's as if like all the tension, the pitch tension is leading towards like that specific pitch. Another way of defining it is that the tonic is the pitch or harmonic center of gravity of a piece. And we often find it at the beginning and at the end of a piece. So for example, here in our familiar melody, the tonic is C, and we find it both at the beginning and at the end of this like little melody. So the concept of tonic is extremely important, but because like it gives you a certain level of stability in the music and meaningfulness, like to a piece of melody itself. So now let's try to listen to this melody and see if you guys like can recognize like the tonic and its function. Okay, we're here, so let's go. Right. Again. Okay, so that final note feels like a rest, right? So it feels we've arrived at a point where like the music can rest. So that's the function of a tonic. Now I'll play a little experiment here. So I'll just erase this final note here by a semitone so that we have C sharp there. Okay, so let's listen if we have that sense of rest now. Right? So that doesn't sound right, correct? And that's because we are hitting a note that's outside of the key. The key of this little melody is C major, and here we have C sharp that's outside of the key. And it sounds like very weird. It doesn't give you like a sense of rest. If anything, it's just like sounds completely odd. Okay, so now let me move on to the other aspect that defines a key, so the mode. So in a way, like the mode is connected with the idea of a scale, and the scale being a way of arranging a set of pitches in a descending or ascending way. So in the Western musical tradition, obviously also in pop music, we use a lot of like major and minor scales, major and minor modes. So here we have on the top, the C major scale, and here on the bottom, we have the C minor scale. So they both start on C because C is the tonic of this scale, but then the difference between major and minor mode is given by the intervals that we have between the notes in the scale. So we have a lot of similarities between C major and C minor. So if you take a look at the first, the second, the fourth, and the fifth elements of the scale, they're the same, but then we have something that's different. So the third note, for example, here in C minor is E flat, whereas in C major is just E. Same thing here for the sixth and seventh notes. So we have A and B for C major and A flat and B flat for C minor. So let's try to listen to these scales and try to figure out the difference that we have there. Okay. My major scale. And now the minor scale. Right? So they are slightly different. There's a different flavor to it. And usually in our Western musical tradition, we associate happiness, joy with the major scale and sadness with the minor scale. Good. Okay, so how many keys do we have like in our system, Western musical system? So we said that a key consists of a tonic and a mode. There are 12 notes that can be tonic, right? C, C sharp, and so on. And then we have two modes, so major and minor. So 12 by 2, we have an overall number that's 24 keys. And so here we have like all the 24 keys. So for example, C major, A minor, G major, E minor. So this is also like another way of notating keys. So you use the uppercase for major keys and the lowercase letters for minor keys, right? So just ignore like all of these sharps and flats, all of these accidentals now. So it's too much like music theory. I don't want to like overwhelm you guys like now, and you don't need that. Now the question is, so why do you need to know about keys? Well, first of all, because we want to pre-process this folk song dataset in a way that makes sense, like key-wise, and also because we want to be able to recognize whether or not our network has been able to learn key, the concept of key, and to use it to form melodies that work well in a tonal concept. So they respect all the ideas that come with a key. So the idea of a tonic that provides you like with rest, and other notes that provide you like with more like tense moments like in the music. So in our folk songs dataset, we're gonna have probably songs that are like in all 24 keys, but we are gonna kind of like reduce all of those 24 keys just onto like two keys, C major and A minor. So that process is called transposition. So when we transpose a piece of music, so we move a collection of notes, a melody, up or down by a given interval. And when we do that, we obviously change the key because we change the tonic of the piece itself. So the important thing to understand here is that still the musical content tends to remain the same. Obviously, like the pitches change, but the relationship between the pitches remain the same. So let me give you an example of what I mean here. So here we have like our familiar melody. This is as we've seen it so far in C major, and over here I've transposed it one tone above and it's in D major. So let's listen to this. Oops, let's go. Right? So it's basically the same musical content, but the second iteration that you had there felt a little bit like higher in pitch. Yeah, we transposed C major to D major there, right? And one thing that I want you guys to understand is that most of the pieces that we'll work with, which are like folk songs, are going to be just in one key. So we can just like safely like transpose, once we know the key, we can safely transpose like the whole piece to another key. In our case, it's going to be like C major if we're dealing with major keys, or A minor if we're dealing with pieces with a minor key. Good. Okay. So now I feel like you guys like have learned quite a lot about like the basics like of music theory that we need like to understand how to deal how to manage and pre-process folk songs, right? But one extra step that we need to do here is to understand how we represent music. So there are so many ways like we can represent music in a symbolic way. So here we just have like the traditional Western musical notation with the score format. But unfortunately, for as good as this format is, we can't use it and feed it directly into a neural network. It doesn't work. So we need to convert it into something else. Now, there are many ways we can convert like these scores into something that makes sense for a neural network. Here, I'm gonna just like give you a couple of examples. So the first one, which we are not going to use, is basically to convert the melody into a sequence where each item in the sequence is a note, basically. And it provides you with information about pitch and duration. So you can think of it as a list, and each item of this list is going to be a tuple, where the first index of the tuple is a note's name, and then the second index gives you information about the note duration, right? So if we used this type of music encoding, we would have like this result over here with our sample melody, right? So this first note here, C4-1, this second note is D4-1, then E4 0.5 because it's a half note, right? So sorry, it's an eighth note here, right? Okay, so on and so forth. I want to draw your attention to this last event over here. This is a rest, so this is a moment of silence, and this symbol over here tells you that this rest is worth 1 bit. So we can indicate that a rest simply with an R. So the R symbol plus the relative duration. Good. So this is like a quite effective way of like representing music symbolically, but we're not going to use this. We're going to use another approach which is more related to time series. Okay. So guys, if you don't remember, a time series is a type of data structure where we have samples that are taken at evenly spaced positions in time, right? So what we're going to do with our melodies is we're going to sample the melodies at each 16th note value. And at each step, basically, like in our time series, we are going to have like each step that represents a 16th note. So whenever we hit a note, so we're going to log the correspondent MIDI note at that specific time step. And then if the note is held longer than a 16th note, we're going to use this underscore symbol just to signal that we are tying that note into the next time step. And then we are using R as the symbol for a rest. Okay, so I feel this could be a lot to take in and a little bit abstract. So let's go and take a look at an example. So once again, we're back with our familiar melody. And so here we know that we are in a 4/4 time signature, which basically means that for each bar, we're going to have 16 samples because we have 16 16th notes in a 4/4 bar. And so for each quarter note, we're going to have 4 samples. And remember, in this case, each quarter note is going to be equal to a beat. Okay, so let's try to just like encode this melody into the time series representation. So over here, so we start with 60, which is the middle C, the MIDI number for middle C, and then we have 3 underscore signs. And duration wise, this is like a quarter note. And so this basically means that we start with 60 and we hold 60 for 3 other 16th notes, right? And so we then move on, and then the second note that we have is 62. Once again, it starts at the beginning of the new bit, and then we have to hold the note for 3 other steps in the series. Then we move on, and for the first time here, we have something that is a little bit different. So we have 2 notes, 8 notes, and so we signal them, we represent them with like their MIDI note number, so 64, and then we just hold them for 1 extra time step because they're eighth notes. Okay, and then again we move on, final bits of the bar, and here we have 65, then we hold the 65, 62, we hold it. Now we can continue, and it could be like a nice little exercise for you guys, just like to try to convert this second bar. But I guess like you get the gist of how this works. Good. Okay. So now the thing that I want to say here, guys, is that this is not the final representation that we're going to use to feed like these melodies into the LSTM network. So we need to do certain adjustments here. So from the time series representation, we have to map this like representation into just integers, right? And that's because of course we have the MIDI notes and they are already integers, but then we have at least a couple of symbols. So the held symbol, the underscore symbol, and the R symbol that are not integers. And obviously neural networks can't handle, LSTM networks can't handle that type of data. So we need to map those into integers. And finally, once we have all integers, we want to one hot encode these integers, right? Now, I'm not going to get into the details of how this is going to work because it's just faster to look at the code when we'll implement that in the next video. But I wanted to give you an overview of the different like steps that we are going to use for pre-processing this data. Okay, so I think that's basically it for this video. I hope you now have like a good understanding of the basic concepts involved with melodies, and this is going to give you like a very good understanding of how our network is going to be like creating music, and whether like the network is going to be able to understand and learn concepts like key, concepts like scale, or time signatures, and the way we distribute like melodies with tonic, tension, and release of tension, right? Okay, so as I said, like this was it for this video. So next time we are gonna go back to, or like for the first time, go into implementation, coding, and we're gonna use all of the information that we've learned from this video and pre-process the folk song data sets and make it almost ready for fitting into our LSTM network. Okay, so I hope you've enjoyed this video. I had a lot of fun like talking about this stuff, and if that's the case, please leave a like, consider subscribing, and if you want to subscribe, remember to hit the notification bell. Okay, so that's all for today. If you have any questions or doubts, just like leave a comment in the comment section below. And as always, I hope I'll see you next time. Cheers.